We have a little Chuck Berry mixed with some status quo, and that gets us to graphing linear equations in two variables, Chapter 1, Section 4. We start with a definition of a linear equation. Let A, B, and C be elements of the set of real numbers such that A and B are not both 0. A linear equation, the variables x and y, is an equation that can be written in this form: ax plus by equals c. Remember, both a and b cannot be 0, and this is standard form for the equation of a line. You guys should be familiar with standard form, with slope-intercept form, and also with point-slope form, but we're starting with standard form first. Alright, now, I have three equations that I want to graph. I only have two sets of axes drawn, but that's right, I'll do B and C on the same set of axes. Right now, even though I know some of you already know what to do as far as graphing and rewriting this equation into slope-intercept form and such, I'm going to graph this by finding a couple of points. I'm just going to create a t-chart here, x and y. I'm going to plug 0 in for x, and I'm going to plug 0 in for y. 0 in for y, 0 in for x. If I plug 0 in for y, I get x is equal to, I have 4x equals 2x equals a half. If I plug 0 in for x, I have 2y equals 2, I have y equals 1. Now, if you want to graph 2 points, even though we're going to get a line here, and one of the 2 points is wrong, your line's going to be wrong. So if you want, maybe you might want to plug in one more point just to play it safe. I feel pretty comfortable with these. I'm going to graph 1/2 0, which is right there approximately, and 0, 1, which is right here. Now I'm going to freehand it. I would suggest you get a ruler. Ask me if I have a ruler. Yes, my wife. Now I'm going to go ahead and graph this. This is why I use a ruler, because my graph is kind of sloppy there, and I have the graph of a line described by the equation 4x plus 2y equals 2. Now, these two equations only have one variable, because either a or b is 0. In this case a is 0, in this case b is 0. Y equals 1 means that all the ordered pairs, all the points that I'm going to graph, must have a y value of 1. This is going to give me a horizontal line. Because if all the y values are 1, and I don't know, doesn't matter what x is, x to the right, x to the left, I'm still going up 1 each time, I'm going to have all the points on this line. I'm going to try to graph it a little bit better than I did the last one. And again, use a ruler, use graph paper. Don't make the same kind of silly, sloppy mistakes that I'm making. Now that's the equation here, b, y equals 1. If I want to graph this one here, it only has the variable x. In this case, b is 0, a is -3. I would probably go ahead and divide both sides by -3 just to write this with the variable isolated. And I have x is -4. Now that means that no matter what my ordered pairs are that solve this, the x value has to be a -4. Back here, when the y value was set and constant, I had a horizontal line. Well, if you want to go ahead and make that guess, this is going to give me a vertical line because all my x values are -4. So I'm going to go -4 to the left and then up or down. They're going to be on this vertical line. 1, 2, 3, 4. Here we go again. And I get a vertical line that's graphed that way. Now, as you can see, this is a function. It passes the vertical line test. This is a function. It passes the vertical line test, but this one is not a function. It is the only type of linear equation that does not describe a function. That gives you a vertical line when it has an x, but it doesn't have a y in the equation. This is a linear equation. This horizontal line is sometimes called a constant function, a linear function, a constant function, then again, not a function at all. Now, lines that are non-vertical are slanted. And this slant that we talk about for horizontal lines and oblique lines describes the way we're going to use to graph the line. Now, if you've ever gone sledding before, and I did as a kid, I lived in Illinois, we would look for the steepest hill possible to gain speed. So if I had a sled and I put my sled down here, off I go. But if I have a sled here, unless somebody's pulling me or pushing me, I'm not going anywhere. So we're going to talk about the way this line is slanted as compared to one of these oblique lines. Here in the upcoming part, we have to define what we call slope. The slope formula, the slope is a number that describes the way a line is slanted, a non-vertical line is slanted, and we can determine the slope of the line by using the following formula that's written up here. The slope of a line passing through distinct points x1 and y1, x2 and y2 is m. We use the lowercase letter m for slope. It comes from a French word monter, which means to climb, like to climb a mountain. This is delta y over delta x. Delta, the Greek letter delta, means the change in the y's, the change in the x's. So as you can see, I subtract the y values, I subtract the x values. Most people think of it as rise over run. Be careful, the denominator cannot be 0, so x sub 2 minus x sub 1 cannot equal 0. So I'm going to find the slope of the line given points. Without actually the graphs, I'm not going to graph these, I'm just going to use the slope formula to determine the line. Well, let's see what we have here. I'll call this x1, y1, x2, y2, if that helps. And my slope is going to be negative 2 minus 1, negative 2 minus 1, all over 2 minus a negative 4. So that's a negative 3 over a positive 6. Simplify, negative 1/2. Usually we like to keep our slope written as a fraction. If you get an integer, that's okay. You can write it as an integer. Just think of it as over 1. But if you get an improper fraction, leave it as an improper fraction. You can reduce it, but don't change it to a mixed number. We like the rise over run effect. Now over here, I threw a fraction in. I'm going to work it the same way. 17 minus 2, negative 3 minus 3/4. So this is 15 on top. Negative 3 minus 3/4 is negative 3 3/4, which is negative 15/4. So this is 15 divided by negative 15/4, which is the same as times negative 4/15. So this simplifies all the way down to negative 4. Both of these slopes are negative slopes. Now there are the two special cases that I was talking about back here. Remember my sled? I'm not going anywhere. Well, on a horizontal line, not going anywhere means the slope is equal to 0. On a vertical line, now I like sledding and I like going down steep ones, but if I went down a hill this steep, I would become undefined. So if it's a vertical line, we either say the slope is undefined or that there's no slope. No slope does not mean the same thing as 0 slope. It means the same thing as the slope being undefined. If we have positive slope, and this one, even though it's kind of drawn poorly, has positive slope, actually, it has negative slope because I messed up. I found my mistake before I finished my video here. This is not 0, 1. This is 0, 0, negative 1. This is supposed to be, excuse me, this was, try it one more time. If I plug 0 in for x, I got y as 1. I did a negative 1, even though it was positive 1. It would be up here. I get another chance to graph this. Ignore this guy. Oh, this is, redemption here on the graph. A little bit better this time. Alright, so this has negative slope as well. And these two guys have negative slope. What does negative tell me? It tells me that for this oblique line, my line goes up and to the left or down and to the right. If it has positive slope, it goes up and to the right, which is usually a fairly easy concept to remember. Positive slope up and to the right, negative slope up and to the left.